Question 1 says write down the value of the 4 in the number 542.3. Well, the 4 represents 40. Write down a square number that is also an odd number. So if we think of the first few square numbers, we've got 1, we've got 4, we've got 9, etc. But we're just looking for one that's an odd number as well. I'm just going to go for 1. Change 4,560 grams into kilograms. Well, to go from grams into kilograms, we need to divide by 1,000. So that is going to be 4.56 kilograms. Change meters into millimeters. Well, to go from meters into millimeters, we have to times by 1,000. So that's going to be 7,300 millimeters. Work out the cubed root of 64. Well, that should be one of the numbers that you should know. You need to really know the first 5 cubed numbers. 4 cubed is 64. So this is just the inverse of that. The cubed root of 64 is 4. And write 0.31 as a fraction. Well, here we've got our units, then we've got our tenths, and we've got our hundredths. So we've got 31 hundredths. Now, question 6 is asking us, write the fractions in order of size. Now, this is the calculator paper. So the easiest way to do this question is going to be to turn them into decimals. So the first one you should know anyway. 3/4 is going to be 0.75. Now 5/7, so all we do is get our calculator, press the fraction button, 5, arrow down, 7 equals, press SD, and we get 0.714. The next one, same idea, fraction button, 19 over 25 equals, press SD. That comes to 0.76, and the last one, fraction 11 over 15 equals, and that comes to 0.73 recurring, so we put a dot on top of that there. So we're not allowed to write these decimals out, we have to write the fractions. So which is the smallest of these? Well, if we put a third decimal place for each of these, that would be a 0 there. That would be a 0 there. We're looking at the 3-digit number after the decimal point. So the lowest of those is going to be 714. So the smallest number is going to be 5/7. And then we'll cross that off the list. The next one after 714 is going to be 733. So that is 11/15. Cross that off. And then we've got 0.75, so 3/4 is your next one, and finally that leaves us with the last one, which is 19 over 25. Now question 7a is simplifying algebra. So we've got 3m minus m minus m. Well, that's going to be 3m minus 2m is m. m plus 3m, our final answer is 4m. Multiplying, let's multiply the big numbers first. 2 times 4 is 8, and then we've got an n and a p. We put them in alphabetical order, so the answer is 8np. Question 8. A map has a scale of 1 centimetre to 14 kilometres. So I'm going to write this scale down, 1 centimetre to 14 kilometres. On the map, the distance between Manchester and London is 18.8 centimetres. So I'm going to write this in the column where we've got the centimetres, 18.8 centimetres. What is the real distance? Well, we can do it one of two ways. We can either go that way, which would be timesing by 14. So we could times this by 14. The other way we could have done it, we could have gone downwards and times both of them by 18. So let's do this on the calculator. Let's do 18.8 times 14. So 18.8 times 14 equals, and we get 263.2. Number 9, it says the nth term of a sequence is 3n plus 4. Explain why 21 is not a term in this sequence. Well, there's a couple of ways that we could do this question. We could work out the first few terms in the sequence. That would be the long way. If n was 1, 3 times 1 is 3. 3 plus 4 is 7. Now, the 3 in front of the n tells us that this sequence is going up in threes. So the next one in the sequence will be 10, then 13, 16, 19, and 22. That's one possible explanation. You see 21 is not in that list there. Another way is we could solve the equation 3n plus 4 equals 21. And if n comes out to be a whole number, it's in the sequence. If it doesn't, it's not in it. So if we solve this equation, I'm going to take 4 off both sides. So I get 3n equals 17. So that means n would be 17 over 3, which is going to be 5 2/3. So explain why 21 is not in the sequence. N is not a whole number. So it's not a term number. Now, there's two answers to the first part of B. So if we've got our numbers 1, 2 and 4, one thing I could see straight away, this could be a multiplication of multiplying by 2 each time. So if that was times 2, so the next two numbers times 2 would be 8. And if I times the next one by 2, it would be 16. And the rule for this one is times by 2. So I'm just going to put that underneath there as well. Another one I could think of is if we've got 1, a 2 and a 4. If we're adding here, we're adding 1. And then here, we're adding 2. So the pattern could be add 1, add 2. The next one could be add 3. So that would be 7. That will be add 4. 7 plus 4 is 11. So the rule is add on plus 1 plus 2 plus 3, etc. Now question 10, we've got a function machine. It says work out the output when the input is 8. So if the input is 8, 8 times 5 is 40. 40 take away 2 is 38 for the first part. We'll work out the input when the output is 28. So what we're going to do for this one, this is the inverse. So we're going against the flow. So if we're doing the opposite of minus 2, we're going to do plus 2. So we're going to do 28 plus 2. So that's going to give us 30. Then the next thing we do the inverse of the times 5. So we do divided by 5, and 30 divided by 5 is going to be 6. So the input to that is 6 using inverses. Now question 11 is asking us to work out the differences between the bonus that Adam gets and what Katie gets. So first of all, Adam gets 30% of 80. So I'm going to write down 30 over 100 times 80, and then I'm going to do that on my calculator. So fraction 30 over 100, arrow to the right, times 80 equals, now his bonus is £24, and that is for Adam. Katie gets a bonus of 28. What's the difference in the bonus that Adam gets and Katie gets? Well, you can see the difference is 28 take away 24 is going to be £4. Number 12 tells us there are 49 counters in a bag. 20 of the counters are red, the rest of them are blue. One of the counters is taken at random. What's the probability that it's blue? Well, to get the number of blues, we need to do 49 take away 20, which is going to be 29. So the probability of picking out a blue counter then is going to be 29 over 49. In question 13, it says a square has an area of 81 centimetres squared. So if it's a square, the sides have all got to be the same. So the length and the width must both be 9 centimetres each. So find the perimeter of the square, that's all the way around. So that's going to be 4 times 9, which is going to be 36 centimetres. Now, the second part shows a diagram of a triangle and a parallelogram. It says the area of the parallelogram is 5 times the area of the triangle. So let's work out the area of the triangle first. So the area of the triangle is a half times the base times the height. So it's going to be a half times 9 times 16. So if we do that on our calculator, that's going to be 72 centimetres squared. The area of the parallelogram is 5 times this. So if we times 72 by 5 times 5 equals, we get the area of the parallelogram is going to be 360 centimetres squared. So I'm just going to write that up there. Now, the area of a parallelogram is its base times its height. So to get the height, h is going to be the area, 360, divided by 30, which is the base. So 360 divided by 30, and the height is going to be 12. In question 14, Victoria throws an ordinary fair-sided dice. So the probability of getting a 3 is half the probability of getting a 6. So the probability of getting a 3 is, how many 3s are there on the dice? There's only 1. So the probability of getting a 3 is 1 out of 6. What's the probability of getting a 6? Well, the probability of getting a 6 on a dice, there's only 1 of those as well. So it's also a 6. So is Victoria correct? No, she's wrong. The probabilities are the same. So Victoria is wrong. Probabilities the same. The second part, Andy throws the dice twice. The probability of getting a 6 on both throws is 2 6. Is he correct? Well, he's got confused because the probability of getting a 6 on each throw is 1/6, but we have to multiply the probabilities. So Andy is wrong. The probability equals 1/6 times by 1/6 equals 1/36. And finally, Indra throws the dice once. She also throws a coin to get heads or tails. List all the possible outcomes she can get. Well, we want to do this systematically. So if she throws a 1, she could then throw a head. 1, then a tail. That's 2 outcomes. 2 and a head, 2 with a tail. 3 with a head, 3 with a tail. 4 with a head, 4 with a tail. 5 with a head, 5 with a tail. And finally, 6 with a head, 6 with a tail.